should take it slow.
Hello everyone. So today we're doing stationary points, specifically maximum and minimum points. Now let's draw a little graph right here. So let's say this is a quadratic function, and of course at the top we're gonna have a maximum point. Now at this maximum point, it's gonna be a stationary point in which there is no gradient. Gradient is 0. So what happens is that at this stationary point at the very top of the graph, dy dx of said function will equal 0. Like the first thing, at stationary points, whether it's point of maximum or point of minimum, the dy dx will equal to 0. Now, let's look at an example of how you would find and classify stationary points. First, we're going to start out with the function 3x squared plus 2x minus 1. Of course, this is a function f of x, so we're going to have y equals all of that. And so, now to go about finding stationary point, we have to first derive this function. And so we're going to say dy dx is equal to 6x plus 2. And since we know that at a stationary point, dy dx must also equal 0, we can say that 6x plus 2 equals 0. And now we will just transpose and find x. If we transpose, you will see that x is equal to negative 2/6, can be simplified down to negative 1/3. Now, of course, it's supposed to be a point, so we would substitute this x value into this equation to get the y value of the stationary point. But for now, we'll just be focusing on the x value because it's what we need to classify the point. Now, we're going to do what's known as the first derivative test in classifying stationary points. So there we go. For the first derivative test, we are going to check to see if the function has a negative or positive gradient on either side of the x value. So firstly, we're going to take an x value that's just slightly smaller than this one, and for that we're going to use negative a half. So we're going to use x equals negative a half and substitute that into our dy dx. Let's write it back. Our dy dx was 6x plus 2. So first we're going to substitute negative a half into 6x plus 2. And of course, 2 into 2 goes 1 time, into 6 goes 3 times. So we have negative 3 plus 2, which would equal negative 1, of course. So when x is slightly less than this value, we have a negative gradient. Because remember, the point of a differential equation is that we get a gradient function. So when we substitute the x equal negative a half into the differential function, we get the gradient at that point, and so we have a negative gradient. Now we pick a value that's slightly greater than a negative one third, and for that we're going to use 0. So when x equals 0, we have 6 times 0 plus 2, which of course equals 2, and so this time we have a positive gradient. Now what this is telling you is that we have a minimum point. Reason being, let's just draw back a graph, and as you can see here, the stationary point on this curve would be way down here, and as we approach a stationary point from values less than it on the x-axis, you can see that the gradient slowly goes down, so the gradient will be negative, and as we move away from it with values higher, you can see that the gradient is going up. So because we have a negative gradient less and a positive gradient more, then we know that it's a minimum value. If it was the other way around, where we had a positive gradient when it's less and a negative gradient when it's more, then we would have a maximum value. In the case where the gradient doesn't change, we have what's known as a point of inflection, but that will be covered in another video. So this was the first derivative test in finding maximum or minimum value. Now we're going to look at the second derivative test. We're going to use a new function this time. We're going to use 4x squared minus 3x plus 2 to do second derivative test. Now of course, as the name implies, we're going to have to derive twice. And so the first derivative would be dy dx equivalent to 8x minus 3 and then the second derivative d squared y over dx squared is equal to 8. So first things first, we're going to use the first derivative to find the x value of the stationary point. And of course, we set the 8x minus 3 equivalent to 0, and we get the x value to be equal to 3 over 8. And then now, to classify the point, we look at the second derivative value. If the second derivative value is above 0, like we have it here, then that is when we know it's a minimum point. If the second derivative value is below 0, then we know it's a maximum point. So the second derivative test can many times be much easier than the first one, but what you must remember is that if the second derivative of the function is equal to 0, it cannot be used. Now, in the case where the second derivative isn't a constant and has a variable, what we would do is we would input this x value into that variable and then use that to classify it. So if this was 8x, instead of 8, we would input this x value into the x here and carry it out, and then again if it's above 0 it's a minimum point, and if it's below 0 it's a maximum point. That will be all for today. Thanks for watching.
Tell me pretty lies.